Hello friends, welcome to Pepcoding. I hope all of you are doing well. In this video, we will learn about a new data structure which is called linked list. So let's see. So what is linked list? It is linear data structure. Second one, it is very similar to arrays. And third one, as its name suggests, it is a list in which the elements are linked to each other, something like this. Why? Why we required linked list? As it is very similar to arrays, so what work is done with linked list can also be done with array. Then why we required it? So let's take an example. I want to store this data, this 5 integer value in this sequence. So each integer value takes 4 bytes. Here are the 5 values, so total memory required will be 20 bytes. If we declare an array, so we will require 20 byte continuous memory, and simply we will store this data like this. But consider a situation that we have this memory. This is our heap. Here we have 10 byte free. It is filled memory. Again 10 byte, again 10 byte, again 10 byte, and again. So here what we have? We have 10, 20, 30, 40, 50 byte free memory, which is more than what we required. But here is the problem that there is no any 20 byte continuous free memory section. So we can't store this data inside the array. And here, to overcome this problem, we use linked list. Okay. So how can I store data here? Let's store 10 here, 20 here, 30 here, 40 here, and 50 here. So data has been stored, but how we will get that these are in this sequence? So what we can do? We can simply store the address of next one with the current data. So let's consider if its address is 100, 200, 300, 400, and 500. Then we store here 200. We store here 200. The address of this one. Here 300, address of this one. Here 400, address of this one. And here 500, address of this. And it is pointing to nothing, so we will store simply null. So from here it is clear that an element of the linked list can be created as this is value part and this is address part, which we can call as next. So it contains the current value and it contains the address of the next address of Next, data memory storage. Okay, so if we declare a linked list, it will be something like this, and it is linked list. This declaration contains three things: head, tail, and size. So in case of our example, it will something like this. 10, 20, 30, 40, 50. The addresses are 100, 200, 300, 400, 500. And here 200 is stored, here 300 is stored, here 400 is stored, here 500 is stored, and here it is the none. Here it will be a node named as head, and here it will be a node named as tail. So it is pointing to this. So here 500 will be stored. It is pointing to this. Here 100 will be stored. And what is the size? It will be the int value which stored this size 1, 2, 3, 4, 5. So here 5 will be stored. Thus the linked list is formed. So let's see the comparative difference between both arrays and linked list. So linked arrays required continuous memory location. It can also utilize segmented memory location. But in the case of arrays, there were the only 5 elements, so we required 5 into, these are of integer type, 4, 20 byte total. But in linked list, as this address of next one is also to be stored, so one node take the memory 4 for this and 4 for this, 8 bytes. So total memory required will be 8 into 5, which will be 40 bytes. So the advantage of the linked list is that it can also utilize the segmented memory location, but it requires some more memory for storing the same amount of data compared to arrays. Okay, I hope all of you have understood all these concepts and enjoyed the video. If yes, please hit the like button, subscribe our channel for more videos like this, and do share this video among your friends. Thank you. Keep coding.